Alright, the 2021 AMC 10B problem 16. It's all uphill from here. Call a positive integer an uphill integer if every digit is strictly greater than the previous digit. For example, 1, 3, 5, 7. It's kind of increasing. They called it an increasing number in the past, I think. 89, and even one-digit number can be called an uphill integer because it's kind of considered increasing the whole way, even though there's only one term. But 32, because it goes down, 1240 because there's a 0 at the end, and 466 because there's two sixes and that's not increasing, are not. How many uphill integers are divisible by 15? Okay, so to be divisible by 15, it has to be divisible by what? 3 and 5. Well, to be divisible by 5, it has to end in 0 or 5, but it can never end in 0 because that wouldn't be uphill. That means it has to end in 5. And since it has to be going uphill, we're looking at, well, one digit, would 5 work for one digit? No, because it's not divisible by 3. So there are no one-digit uphill integers divisible by 15. We will start with what I call case 2, which would be 2 digits. If it's going to end in 5, the digit sum has to be a multiple of 3. So that's going to be 15 and 45. That's it for case 2. There aren't any others. You only have access to the numbers 1, 2, 3, and 4 besides the 5. You don't even have access to 0, so you can't use it. Keep that in mind as we go to case 3, because case 3 got a few people with its trap part of the answer here. If it's going to end in 5 and have 3 digits, right, then what could it be? Well, could it be 6? Like the sum of the digits is 6. Well, that would be if you could do 1, 0, 5, but 1 to 0, again, if you told yourself that 0 is not accessible for any reason, you don't even need to think about it, it's not going to be there. Some people didn't catch that and included this. They ended up getting the wrong answer, which we'll get to in a moment. Okay, so the next one would be if a sum of 9. Well, if I have a sum of 9, I'm going to need these two to add up to 4. They could be 0, 4. Can you start with 0? No, because it's not going to be a 3-digit integer. It would be the 45 that we already had. You can't consider 0 as the first digit of a 3-digit integer. It could be a 3-digit number, but it wouldn't be like an integer. Yeah. Kind of like a code or something, like a lock could start with 0, but if we're talking about strictly integers, then that's not going to be possible. Okay, so we have to have a sum of 4. If I use 1 and 3, we could do it. 1, 3, 5. Are there any others that add up to 4? If I use 2, I'd have to use a number 2. That's it. There's no more that add up to 4. 3, 1, 5, but that's not uphill. So we go, don't just end there. That's only a sum of 9. What about a sum of 12? You would need to have 7 right here. Can you have 7? You sure can. There's a 3 and a 4. So 345 is going to get you 2 cases here. You've already got 2 cases there. All right, let's go to case 4. Case 4 is going to be a 4-digit number that ends in 5, creatively named, right? So then we're going to need a sum of 6, impossible. How about a sum of 9? I would need 3 numbers that add up to 4. Even if I take the smallest 3 numbers, it's not going to work. That's going to be already 6. So because of that, we're going to have to target a sum of 12, digit sum of 12, meaning these 3 have to add up to 7. 3 and 4 won't work because you'd have to use a 0, and we don't have that. If I take 4, 2, and 1, that's going to get us 7. 1, 2, 4, and 5. There's no other combinations that work. I would have to include 4 because the sum of these is only 6, and 4 with 3 is already 7, so 4, 2, and 1, the only case 4. We're on to case 5. 1, 2, 3, 4, 5, and it has to use all 4 digits. Does it work or not? Well, add up the 1 to 5, you get 15. That's a triangular number. 1, 2, 3, 4, 5. One more case, 2, 4, 6 cases. Let's get to problem 17. All right, guys, we are now on the 2021 AMC 10B problem number 17. Incidentally, this question, in my opinion, is directly connected to the 2004 AMC 8, problem 18. If you go look that problem up, I will link it in the description at some point when I have time, but today I probably don't have that time. It's 5 friends competing in a dart throwing contest. It is a very similar tactical approach to this problem here. Let's get into it. Ravon, Oscar, Aditi, Tyrone, and Kim play a card game. Each person is given 2 cards out of a set of 10 numbered 1 through 10. The score of a player is the sum of the numbers of their cards. The scores of the players are as follows. Ravon, Oscar, Aditi, Tyrone, Kim. Which of the following statements is true? Don't read them. Go and analyze, okay? And so the way it's going to work, just like in the dart throwing competition from the 2004 AMC 8, which again, do all the past contests. Your experience informs you exactly how to approach this. If you just recall that question, take the most restrictive person, Oscar, right? They're given 2 cards. They cannot have 2 2s. There is no 0. Oscar must have 1 and 3. Guaranteed. Nothing else you could have. Next person up is Aditi. She's the next lowest score of 7. Analyze. Can she have 4 and 3? No. 3 is right here. Can she have 1 and 6? No. 1 is already in use. She or he must have 5, 2. I don't know if that's a male or female name. Okay, so 5 and 2 here. The next most restrictive is Ravon. Could she have 10 and, it could be he as well, I don't know. 10 and 1, no, 1's in use. 2 in use, 3 in use. 4 is not in use, so we could do 4 and 7. 5 and 6 can't do it. Only 4 and 7 can be Ravon's score. Tyrone 16, where are we at? We can't use 1, 2, 3, 4, or 5. We're going to have to use 6. It's probably 6 and 10. Let's just see if anything else works. If I tried 7 and 9, no. Double 8, can't do it. Got to be 6 and 10. Kim, we're continuing it on, even though the answers don't have this. We just want to feel rock solid in our answer. So then 17 is going to be what's left. There is a 9 and an 8, and that's going to be what goes there. Every number is represented once. We haven't made a mistake. Let's go analyze. Was Ravon given card 3? No. Has 4 and 7, not A. Aditi was given card 3. No. Oscar has it. C. Ravon was given card 4. That's correct. It looks like C. Should you just move on? No. It doesn't take that long to verify the other answers don't work. Do it really quick for peace of mind. D. Aditi was given 4. Definitely not true. Ravon has it. Tyrone was given 7. Ravon has that too. Good game. Let's get on to problem 18. All right. This is the 2021 AMC 10B problem 18. And this problem seemed a little dicey to me. A fair 6-sided die is repeatedly rolled until an odd number appears. What is the probability that every even number appears at least once before the first occurrence of an odd number? Now, I did spend a little bit of time thinking about this, and then even under timed conditions, I wasn't able to actually get it, but I returned to it a little bit later after I did my timed mock test for myself, just to have a rough estimate of how long it took me to do the whole test. And I thought of a way that you could do it. Basically, all of the numbers, if you imagine you keep rolling the die until all 6 numbers appear, right? Regardless of whether a number got repeated, like 2, 2, 4, 6, 1, 3, 1, something like, whatever. Just imagine that all 6 numbers have appeared once, right? And after that happens, all the repeated, we just ignore it. And the reason that we can do that is because it's kind of like, I don't know, like board states or something. It's all going to kind of wash out in the symmetry. I don't know how to explain this properly, but basically, if you just think that at some point, if you roll infinitely, all 6 numbers will appear, and the number of ways that you can arrange the first appearance of each of those 6 numbers, regardless of what happens in between, is going to be 6 factorial. So consider only the first appearance of each number and ignore everything else. Then, in all such sequences, there will be 6 factorial ways for the first appearance of all of the numbers to occur. how many of those ways have all of the even numbers come first? Well, if you take your even numbers, 2, 4, 6, how many arrangements do they have? 3 factorial, that's going to be 6. Then, afterwards, you would need to have your odd numbers make their first appearance, and they also have 3 factorial arrangements, which is 6. So now you can do this. Let's go ahead and simplify. This will be 6 times 6 over 6 times 120. 6 times 120, 5 factorial is 120. Good to memorize your first 6 or so factorial, maybe even 7. 7 factorial is 5040, I believe. Memorize those. They come up a lot. That can save precious time. So this is going to cancel here. 6 goes into 120. 20 times. The answer is C, 1 over 20. Yeah, kind of a great, I don't know, it's so simple when you think about it. If you just ignore all of the other potential dice rolls, the repeated dice rolls, doesn't matter at all. Just think of only the arrangements of the first appearance of each die and how many of those, and then you separate. Easy, done. Let's get on to problem 19. All right, this is the 2021 AMC 10B problem 19. It was also the 12B problem 12. Lots of reading. This is an averages problem, and they've done so many averages problems before. I imagine it's becoming increasingly difficult to come up with a new way to ask you about averages, which means this problem is probably above average difficulty for an average problem. Well, an average concept problem, the concept of averages. Let's get started. Suppose that S is a finite set of positive integers. Great. If the greatest integer in S is removed from S, then the average value, also called the arithmetic mean, of the integers remaining is 32. We need to find a way to represent this info. My averages formula, again, is the sum of n things divided by n is the average of those n things. So, we need to have some way to represent what just happened. It's the set S. I don't really want to use S. We'll say that there's U terms within the set of S. So it's going to be the sum of, in mine what I wrote was U, meaning all of the terms in S, minus L, meaning the largest term has been removed. Again, this is a subscript. It's just a notation to myself to indicate what's taking place. This will be the sum of the entire set of the values in S, the universal set, minus the largest number in that set. And then if I do that, it will be over U minus 1 because the number of numbers in the universal set S minus 1 entry, the largest entry, this is going to be 32. And then you're also going to need to immediately multiply. You will get that the sum of the universal set minus the largest value of that set is going to equal 32U minus 32. Okay, then we have to keep reading. If the least integer in the set S, it has it in italics. I can't write in italics, so I just underlined to kind of indicate they drew extra attention to it. In S is also removed, so also in addition to the L, I'm going to call this the sum of U minus LS. L meaning the largest and the S meaning the smallest. So they're both removed, so now we've got 2 less terms than the universal set has in it. The average of the integers remaining is now 35. And again, you will get the sum of U minus largest and smallest is going to equal, bring this over here, 35U minus 70. Okay, next up. Finally, if the greatest integer is then returned to the set. In other words, we return it so we're only missing the smallest one, U minus S. Okay, S. Can I draw an S? Good. Divided by, we're back to being U minus 1 because there's only one number missing. We put the largest number back in. The average value raises to 40. So this is going to be 40. And now we have the sum of u minus the smallest is going to equal 40u minus 40. So 40u minus 40. Okay, now what do? The greatest integer in the original set, s, is 72 greater than the least integer in s. What is the average of all the values of the integers? So we actually want to find the sum of u over u. This is the goal of the problem. But we've got one more piece of information we haven't used yet, and we've got to figure out how are we going to use it. So I had to kind of think about this, and I actually did a trial. I just made something up. I said, what if I had 2, 3, 5, and 11? And I found the sum of, we'll call it t minus l. The total of the values here minus the largest would be 10. And the sum of t minus s, the smallest value removed, is going to be 19. And I noticed that the difference in these two, 9, was equal to the difference between the largest and smallest. I suspected this was always the case. Now, some of you might have just processed this and thought about it great, but for me, I kind of have to prove things to myself a little bit sometimes on the test, so I feel more sure that it's going to work. I then did a second case. It confirmed exactly what I suspected, and it makes sense, right? When you think about it, if you took out the largest number from the set, you're missing one number, take out the smallest number. The difference in those sums is the difference between the largest and smallest numbers, and that's what it tells us right here, which means if I take this one and this one, these two sums, and subtract them, right? The sum when you take out the smallest is always larger than when you take out the largest, right? So if I take that 40u, I subtract 32u, I will get 8u. The negative 40 minus a negative 32 is going to be negative 8. Okay, I'm taking that, I'm subtracting that. The result needs to be 72, the difference between the largest and smallest. This is what you can do anytime you don't fully understand what they mean by something. Make a simple case, apply what they're talking about in the more difficult case, figure out something that you can learn from that, take what you learn and apply it to the more difficult case. AOPS teaches this all the time in their books. It's a great approach to problem solving. Add 8, get 8u equals 80, u equals 10. So now that we know that u is 10, what can we do with that? Well, let's go to the sum of u minus l. It's going to be 320 minus 32. Also, you could say that since u is 10, it would be 32 times 9. So 32 times 9 would be 270, and 18, it's 288. So the sum of u minus l would be 288. Is that right? 270, 18, 288. No, something's not right. 32, wait, hold on. Sum of 10 minus 1, 9, 288. Guess that would be right, yeah? Okay, and then how did I get before? 320 minus 32, that is, 88. I don't know what I'm thinking. Okay, so then the next one will be the sum of u minus L and S. And the sum of u minus L and S is going to equal 350 minus 70. So 350 minus 70 would be 280. This indicates that the smallest value, because the only thing different in these two is the smallest value is missing, the smallest value must therefore be 8. And since the smallest value is 8, we can simply add the smallest value back into this, and we're going to have 40 times u, which would be 400, minus 40 is 360. We're just taking this sum down here, plugging the 10 value of u in, and we now have that we'd have a sum of 360, but we know that the smallest value is 8 because the only difference in these two is 8. So we're going to add the smallest value back in because this is the universal set minus the smallest value. If we add it back in, it's back to being full. You get 368. You now have to divide that by the number of terms 10. You're going to get 36.8. Answer choice D. A very difficult averages problem. If you didn't get it, I totally understand. I hope you understand how to apply. This is a basic concept. We got a little complicated. We had to invent notation. A big secret to success on the test is how good of notation you can invent. I've never written something like this. I've never seen something like this written. I had to come up with a way to represent what they were talking about. You're going to have to do that too if you're going to succeed. Let's get on to the next problem. Hey, how's it going? So we're on the 2021 AMC 10B problem 20, which is the last problem of the set of 5 from 16 to 20 for the 10, and the last problem of the set of 5 for 11 to 15 for the 12. This is a really fun question. I think the MAA test designers, whoever designed this problem, really great question. Let's get into it. The figure below is constructed from 11 line segments, each of which has length 2. Okay, what do they mean? I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 total line segments, all right. The area of pentagon ABCDE can be written as the square root of that, blah, 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 positive integers, find their sum. Okay, let's get to figuring out what the area is, because that's in essence what we're doing. Since it's a regular pentagon, each of the interior angles must be 108, which would make, since these are all equal, this is 60 and this is 60, but, oh, that would mean it's not 108. But how, I thought it, no, it never said regular pentagon. It doesn't say it at all. Don't infer what it doesn't say, right? Unless you can base it on really solid logical reasoning, but the assumption that equilateral pentagons have to be equal angular is an incorrect assumption. And so what can we do? Well, I thought about when I solved it, I thought if this is 60 and 60, 60 here, call this x, and this is 180 minus 2x, and so is this. I could connect that. Maybe this is, and didn't work. That's kind of a lost cause. I also thought about folding out the triangles and maybe trying to find their areas and then like subtracting the area to get the middle. No, doesn't work. So you're going to have to go back to the drawing board, and the secret comes down to actually seeing, once you've written this as 60 and 60, and something else helped me too. It said all the lengths are 2. That's why you know those are 60, by the way. They're equilateral triangles. So this is 2 and 2. But once I'd written that and I'm looking at these 60s that I wrote, that's when it triggers. Your brain will trigger thoughts when it sees things on paper. Don't think that if you only have it in your mind, you'll be able to see it. No, in fact, when you're visually looking on your paper at something like this, it'll probably trigger an event for you as well. And what is that event? Well, if I just connected A to C, because now I have an isosceles triangle, I'm going to rotate that isosceles triangle to confirm what we suspect. Namely, that this is 120, so I'll cut it off here and get 60, because that's what's happening. This would be A, B, and C, and this is 2 and 2. Now, as such, when you drop an angle bisector of a isosceles triangle and isosceles triangle, let's use proper grammar, then this is going to be a perpendicular to the base, and it's going to cut the base in half. I'm not going to prove this to you right now. You should learn it in geometry. You can look up proofs of why that's the case on your own. We don't have time in this video to break that down. So this will be 30 degrees for sure. Opposite 90 is 2, opposite 30 is 1, opposite 60 is root 3. This will also be root 3. And we can do the same thing on the other side, which gives us ACD, another isosceles triangle. And so we've got ACD, and we know what AC is. It's right there. It's 2 root 3, 2 root 3, and 2. We now have 3 regions, ABC, ACD, and ADE. These 2 regions on the side are identical. Let's find this one. We'll drop the altitude here. Again, same thing. We know it's an angle bisector. 2 congruent right triangles are created, 1 and 1. Let's do Pythagorean. 1 squared plus the height squared equals 2 root 3 squared, which is 12. 4 times 3, move the 1 over, get 11. H is root 11. Now that we have that height, let's do the area of the triangle. A lot of times in the past, I would try to be so fast and say, well, I've got half the base right here. I'll just do half the base in one shot times the root 11. But you know what I did once? After I had taken half the base, and I bet you've done this too, if you've thought like me about how cool it is to perceive that this is half the base and all those 1.3 seconds you're saving, I cut it in half again, forgetting that I had already cut the base in half. And ever since I made that mistake, I don't do this anymore. I'm going to write the whole base of 2 and not the half the base, which is what 1 is. And I do that as a precaution. I know if I write the full base and the half, I'm not going to make a mistake. This is mistake prevention. You're preventing yourself from making a mistake. Okay? So that doesn't allow you, yeah, it's cool to save 1.2 seconds, but is it cool when you miss your AMC qualification because you made it one time out of 100, you failed to realize you'd already cut it in half? Definitely not worth it, guys. Take the extra step, in my opinion. So root 11 is this area of this triangle. Now we've got to do these. Now you could do 4 triangles. My preference, fold this over so it becomes a rectangle. Now it's a 1 by root 3 rectangle made up of 2 of these side triangles. That area is root 3. These 2 over here are the same size. They will also be root 3. It's plus 2 root 3. So now what? If we're looking at that, I don't see any constant like a P or Q in front of the root. I thought it said that no, it doesn't. It doesn't say it's simplified. It says it can be written like this, which means we need to get the 2 back inside. We already know that that is root 12. So root 12 is going to be what goes there. Basically, you make the 2 root 4, and then it's times root 3 still, root 12, root 11 plus. 11 and 12 are M and N. That gives us 23. Michael Jordan, also LeBron James. That is it, guys, for this problem. Again, really great. One of my favorite ones on the test, because you had to think a little bit about, take some false paths, if you will. This problem definitely took a little bit of time to develop for me, and it was when I wrote the 60s here and looked at these 2s, game was up. Let's get on to the next problem. I'll see how much time I have to film today. I might not have that much more time to film. I got some teaching to do a little bit in a little while. Okay?